Hey guys, this is Elena Seungeun Lee from Willing to Share. In this video, we're going to derive how to get the moment of inertia. So this equation, this formula of an annular cylinder ring about a central axis. But before we start, let's just make one thing clear so that we can visualize this solid even better. So this is how this solid figure would look, with the axis going right through the center. And we have the smaller radius r1, the bigger radius r2, and the height of h. In this case, we can say that the volume of this solid would be equal to the bigger radius times pi h minus r1 square pi h. So it will be same as this when it is simplified. Okay, having that set, we're gonna divide this annular cylinder into thin concentric rings that will look like this. So we'll just say that this is x, and the thickness over here would be dx, and this would be h. And we could have that pi equals m over v, the mass density. And this is the same as dm over dv. And so you can say that dm is equal to pi dv, right? And for the ring, the dv, for this ring that you have divided, the dv of this ring would be equal, so the dv of this ring would be equal to 2 pi x, which is the circumference, times dx, which is the thickness, times h, the height. And therefore, if you apply this into here, you will have dm equals pi 2 pi x dx h. Now let's get the moment of inertia. So for the moment of inertia, you would have integral x squared dm, right? And for this case, you're going to integrate it from r1, so from here to here, because this is the actual solid that is left, right? You don't have the inner side. So you're going to integrate it from r1 to r2, from over here to here. So you would have r1 to r2, and your x squared, and substituting dm inside here, so pi 2 pi x dx h. We're going to put the constants out, so it'll be pi 2 pi h integral r1 to r2, and you have x squared and x, which is equal to x cubed dx. And if you integrate this, you would have 1 over 4x 4 squared, and you would have r2 to r1, which is equal to, you can leave 1 over 4 out, as r2 or r2 4 minus r1 4. And therefore, if you simplify this, you would have pi h over 2 and r2 minus r1 4 squared. And remember that we have this value left, right? And for pi, we have already derived it, right? Because pi is equal to m over v as a mass density, as a mass volume, you would have this thing right over here. You would have r2 squared minus r1 squared pi h, right? Over m. And therefore, if you substitute this value inside here, you would have 1 over 2 times m 2 squared minus r1 squared pi h times pi h minus this. And this will cancel out. And you can know that this is equal to 1 squared r2 squared plus r1 squared plus by factorizing. And you could delete these two out, and now it will be 1 over 2m r2 squared plus r1 squared, which is the formula we have over here today. So thanks for watching, and see you in the next video.